Cardiovascular physiology, temperature regulation explained. A deep dive into how the heart and blood vessels keep us warm or cool. Welcome to today's episode, where we will explore the fascinating world of cardiovascular physiology and its pivotal role in temperature regulation. While maintaining body temperature is a process that involves many organ systems, the cardiovascular system is at the very center of this orchestration, acting as the primary effector for thermoregulation. Understanding how our bodies balance heat gain and heat loss is crucial for appreciating the delicate equilibrium our physiology maintains every moment of our lives. The core principle: balancing heat gain and heat loss. Human core temperature is kept within a remarkably tight window, typically between 36.5 and 37.5 degrees Celsius. This stability is governed by a set point in the hypothalamus, our body's own thermostat. The secret to this balance lies in the dynamic interplay between producing heat and losing heat, with the cardiovascular system directing traffic by adjusting blood flow throughout the body. The role of the cardiovascular system in thermoregulation. The cardiovascular system is essential for both preserving heat and facilitating heat loss. When the body needs to conserve heat, blood flow to the skin is restricted, keeping warmth deeper in the core. Conversely, when it is time to dissipate excess heat, the system dramatically increases blood flow to the skin, allowing heat to escape into the environment. The hypothalamus, the body's thermostat. At the heart of temperature regulation lies the preoptic area of the hypothalamus. This region receives signals from thermoreceptors located both centrally within the brain and peripherally in the skin. These sensors detect core and environmental temperatures, integrating this information and comparing it to the biological set point. The hypothalamus then sends instructions through the autonomic nervous system to the body's effectors, primarily by adjusting blood flow to the skin and regulating sweating. Mechanisms of heat loss. When core temperature rises. When our core temperature climbs, the body's goal is to transfer heat from the core to the skin and then into the environment. The primary cardiovascular response is vasodilation, widening the blood vessels in the skin. This process is driven by the hypothalamus, which inhibits signals that would normally keep the skin vessels constricted. As a result, blood flow to the skin increases dramatically, shuttling warm blood from the body's interior to its surface. Heat is then released through conduction and convection. However, this widespread vasodilation reduces the resistance in the body's smaller blood vessels, which could lower blood pressure if not compensated. To maintain normal pressure, the heart responds by pumping more vigorously, raising both the heart rate and the amount of blood ejected with each beat. Simultaneously, blood vessels supplying the digestive organs and kidneys constrict, shunting more blood toward the skin for cooling. Sweating is another powerful tool for heat loss. The hypothalamus stimulates sweat glands through special nerve fibers, leading to the production of sweat on the skin. As this sweat evaporates, it absorbs a significant amount of heat, cooling the body efficiently. However, losing too much fluid through sweating without adequate replacement can decrease blood volume. This reduction makes it harder for the heart to maintain both blood pressure and cooling capacity. Mechanisms of heat conservation and production. When core temperature falls. When the body's core temperature drops, the primary aim is to minimize heat loss and boost internal heat production. The hypothalamus increases signals to constrict blood vessels in the skin, greatly reducing blood flow to the surface. This shunts blood away from the cooler exterior, creating an insulating layer of tissue that minimizes heat loss. This vasoconstriction increases the resistance in the small blood vessels, which would otherwise raise blood pressure. The heart compensates by slowing down, maintaining stable pressure. Other mechanisms also come into play. Piloerection, or the contraction of tiny muscles at the base of hair follicles, makes hair stand on end, useful for furry animals but less so for humans, where it simply causes goosebumps. Shivering, on the other hand, generates substantial heat through involuntary, rhythmic muscle contractions. This process can multiply heat production several-fold and demands increased blood flow to the muscles and a higher cardiac output. Additionally, non-shivering thermogenesis involves the activation of brown adipose tissue. Under the influence of certain hormones, this tissue increases the metabolic rate of cells, producing heat without muscular activity. Cardiovascular challenges and pathological conditions. Now, let us discuss how the cardiovascular system faces special challenges during extreme situations. Exercise in the heat. During physical activity in hot conditions, the body must deliver blood to the muscles for exercise and to the skin for cooling. Two competing demands. The heart works harder to meet both needs, but if its capacity is outstripped, blood pressure can fall, potentially leading to fainting from overheating. Fluid loss from sweating further complicates this delicate balancing act. Fever. When an infection triggers a fever, substances known as pyrogens reset the hypothalamic set point to a higher temperature. The body responds first by conserving heat and shivering, making you feel cold. Once the new, higher temperature is reached, the body maintains it until the fever resolves. When the set point drops back to normal, the body shifts to cooling mechanisms, vasodilation and sweating, resulting in intense feelings of heat and perspiration. Hypothermia. In cases of severe cold exposure, core temperature can fall to dangerous levels. Initially, the body responds with vasoconstriction, increased heart rate, and elevated blood pressure, but as temperature declines further, the heart's ability to contract deteriorates, leading to slow heart rhythms, reduced cardiac output, and, if uncorrected, life-threatening arrhythmias. Summary: the cardiovascular system is the thermoregulatory conduit. In summary, the cardiovascular system acts as the primary tool the brain uses to preserve thermal balance. By continuously and precisely shifting blood flow between the body's core and skin, it serves as a dynamic and efficient radiator, ensuring that our internal environment remains stable despite external fluctuations. This intricate dance between the heart, blood vessels, the nervous system, and the environment is central to our survival and daily function. Thank you for joining us on this deep dive into temperature regulation. Stay tuned for more episodes exploring the amazing intricacies of human physiology. If you enjoy our content, please like, share and hit the subscribe button. It's the Everything Surgery Podcast. Dissect the extraordinary.